So in today's video, we are going to use the object spread operator. We will be discussing it in detail and we will be understanding the different aspects of the spread operator. Since one of the core tenets of Redux is to never mutate state, you will often find yourself using the Object.assign method to create copies of objects with new or updated values. For example, I will show you an example. In my components, I'm going to create a new file, that is to do app.js, and using RFCE I will create my functional component. Okay, so we'll have to hard code. So import React from React, then function to do app, return, and then export default. Okay, so here we are going to initially have a state set to initial state, although we haven't defined that right now, and action. Next we're going to add our switch taking action dot type, and then we will add our cases. So the first case is set visibility filter. Here we are going to return object dot assign state visibility filter assigned to action dot filter, and then the default case. So in default we will return state. We don't have all of these created right now, so we are getting the errors. That is fine. So while effective, using Object.assign can quickly make simple reducers difficult to read given its rather verbose syntax. So this reducer to do app is going to be difficult to read because of the Object.assign. An alternative approach is to use the object spread syntax, recently added to the JavaScript specification. It lets us use the spread operator, that is the three dots, this is known as the spread operator, to copy enumerable properties from one object to another in a more specific way. The object spread operator is conceptually similar to the ES6 array spread operator. So after this complex code, we can simplify this into changing the return statement as follows. So we will remove this, and then inside our return we will just add the object using the spread operator state and then visibility filter, which is set to action dot filter. Talking about the object or rest and spread properties of the ECMA script. So ECMA6 introduces rest elements for array destructuring, assignment, and spread elements for array literals. What are the rest elements? The destructuring assignment syntax is a JavaScript expression that makes it possible to unpack values from arrays or properties from objects into distinct values. The object and array literal expressions provide an easy way to create packages of data. The destructuring assignment uses similar syntax, but on the left hand side of the assignment to define what values to unpack from the sourced variable. So for example, we create a const x. This is an array which has 1, 2, 3, 4 and 5 as its elements. And then we are creating const y and z. This is assigned to x. So if we do a console.log for y, we are going to get the value equals to 1. And if we do it for z, then we will get the value of 2. So this is how we destructure arrays using this syntax. A variable can be assigned its values via destructuring separate from the variable's declaration. For example, I set a variable let a comma b, and then I assign a and b different values which is equals to 1 and 2. So now if I do a console.log for these separately, for a and b I will get 1 and 2 respectively. In an array destructuring from an array of length n specified on the right hand side of the assignment, if the number of variables specified on the left hand side of the assignment is greater than n, only the first n variables are assigned values. Next important thing is default values. A variable can be assigned a default in the case that the value unpacked from the array is undefined. So again, in this case, I'm going to consider two variables a and b, and then we are going to add values to these. A and b is assigned to 7, and then we're assigning it to 1. So now if I write console.log a, I'm going to get 1, and for b I'm going to get 7. This was all about the rest elements. Now talking about the spread elements. Spread syntax allows an iterable such as an array expression or string to be expanded in places where 0 or more arguments for function calls or elements for array literals are expected, or an object expression to be expanded in places where 0 or more key value pairs for object literals are expected. The spread syntax can be used when all elements from an object or array need to be included in a list of some kind. For example, let us see an example. I am defining a function sum which takes x, y, and z as the argument, and it returns x plus y plus z. So now if I add const nums, and it has the value 1, 2, and 3, and now if I do a console dot log of sum with the argument nums, this gives me an output of 6, that is 3 plus 2 5 and plus 1. Also if I do another console.log statement, so console.log, then I'm going to write sum dot apply, and inside that num, first argument is null and the second is nums. This will also give me the same output, that is 6. So here also the output is 6. So here the defined function takes x, y, and z as arguments and return the sum of these values. And array value is also defined. When we invoke the function, we pass it all the values in the array using the spread syntax and the array name, that is nums. If the array contained more than 3 numbers, for example 1, 2, 3, and 4, so it would still work fine, except that all 4 would be passed but only the 3 would be used unless we add one more argument in the function, that is along with z if I add a. And here also if I add a, only then, otherwise it is just going to consider the first 3 elements. This example is somewhat rigid. The real value in spread syntax is that it works with the same value no matter how many elements are contained in the object or array. It is commonly used when we want to add a new item to a local data store or display all stored items plus a new addition. So a very simple example if we consider, then it is going to look like, so first we are going to say let num store is 0, 1 and 2, and let new store is equals to 12. So num store is assigned to the previous copy of num store and new store. So in this example, we can rerun the last line as many times as we like to keep adding an additional 12 to this array. So here, along with the previous copy, we will be adding this new store or new number. Let us change this also to new number. So as many times as we run this statement, we are going to add 12 inside this array. So the rest syntax looks exactly like the spread syntax. In a way, rest syntax is the opposite of spread syntax. In simple words, the spread syntax expands an array into its elements, while rest syntax collects multiple elements and condenses them into single element. Now back to our properties of the ECMA script. So the REST properties. REST properties collect the remaining own enumerable property keys that are not already picked off by the destructuring pattern. Those keys and their values are copied into a new object. So for example, this is REST properties. So I will comment it out first. So here, first we are going to add let, and here x, comma, y, and lastly z. This is assigned to x1, y2, a3, and b4. So here x gives the value 1, y gives the value 2, and z gives the value of a and b both. So this is a3 and b4. This is the spread property. This is the rest property. Rest properties. Now talking about the spread properties. Spread properties in object initializers copies own enumerable properties from a provided object onto the newly created object. For example, let n is assigned to x, y, and z. So now if we print n, so we are going to get this output as x assigned to 1, y assigned to 2, a assigned to 3, and b assigned to 4. So an alternative approach to use the object spread syntax recently added to the JavaScript specification is the spread operator. It lets us copy enumerable properties from one object to another in a more suitable way. The object spread operator is commonly similar to the array spread operator. Now, talking about the advantages of using the object spread operator. The advantage of using the object spread operator becomes more apparent when we are composing complex objects. Easy to use complex objects. So for example, if we have a statement here, so here return get added IDs is a function. It takes state dot cat as the output and then dot map where the ID is assigned to object dot assign, and then we are going to add some properties like get products and then state dot products and ID. So next we are going to add quantity get quantity, and then we are going to add a state dot cart and ID. So this is the old method where we are using object.assign. So this is being a little complex. So now if we remove this, we want to map the same objects using the spread operator, then we're just going to remove the object.assign, and then instead of this we will just add the spread operator to bring the last copy of get products, and then we will just map it. So it is much easier to use the spread operator. While the object spread syntax is a stage 4 proposal for the ECMA script and accepted for the 2018 specification detail, we will still need to use the transpiler such as Babel to use it in the production system. So we already have Babel included in React because that is what converts our code, that is what reads our code. So you do not have to worry about that. So that was all about the object spread operator and understanding the spread operator and its aspects. So do like our video. We bring to you videos on React.js and Redux on a daily basis for beginners. So do like our video, subscribe to our channel, and I'll see you in the next video.